Now here's another problematic integral. I look at this and right off the bat I say, well, this isn't like the other ones. I don't have limits of infinity. So what's the problem with this one? Why can't I just raise the power by 1 divided by it? Well, this integral is a problem because of that 0 that's right there. Because that 0 is, within that function, would create a divide by 0 situation. And I can't have that. So I identify that that's where the issue is. And again, to handle this properly, I say, well, it's okay to have some limit down here. So I'll just call that limit a. And I'll say as a approaches 0, and it has to approach it from the positive side. I can't have negative values of 0, right? Or values of x in a square root. And then I have the integral from a to 1. And I'm going to go ahead and rewrite this as x to the minus 1/2 dx because that's the form I would want it in order to integrate it. Limit as a approaches 0 from the positive side, raise the power by 1 and divide by 1/2, which is the same as multiplying by 2, and evaluate that at 1 and at a. And I plug in 1, I get 2 times square root of 1 minus 2 times square root of a. Now I can let a reach that limit. A approaches 0, that means this term just goes away, and I get a total value of 2, because it'll be 2 minus 2 times 0 as I insert that limit of a approaches 0. So what we have to be careful for is if we have a denominator, whether it's that or, we could have dx over 1 minus x, and my first thought on that is, well, that I can make that into a du. It's not going to be a problem. It's going to be a natural log. It is a problem if it goes across 1. If I say that's the integral from 0 to 2, we've got a problem at 1, and we would have to look out at that point at 1 because of the fact that it creates that kind of issue.